Right now, somewhere in the world, a person is feeling pain in a hand they no longer have. They can feel it burning, they can feel it cramping, they can feel every single finger curling into a fist they cannot open because the fist does not exist. And the strangest part, the brain causing that pain is working perfectly. This is phantom limb pain. And what it reveals about your brain is more unsettling than the pain itself. You already think of pain as something your body sends upward. You hurt your knee sends a signal, your brain receives it. Simple, clean, logical. But that model is wrong. Or rather, it is radically incomplete. Because your brain does not just receive pain, it manufactures it. And phantom limb pain is the moment that factory runs with no raw material at all. Let's go back to where this begins. When a limb is amputated, the nerves at the site of amputation do not simply go quiet. They fire chaotically. They send scrambled, disorganized signals up toward the brain. But here is the thing your brain cannot handle: silence. It expects input from that arm. It has been receiving input from that arm since before you were born. And when the input stops or becomes noise, your brain does not accept that the limb is gone. It assumes something is wrong. And what your brain does when it thinks something is wrong with your body is generate pain. That is not a malfunction. That is your brain trying to protect you. But the story goes deeper than confused nerve endings. In the early 1990s, a neuroscientist named Vilayanur Ramachandran began working with amputees at the University of California, San Diego, and what he discovered rewrote how scientists understood the brain. His patients were reporting something strange. When their face was touched, they felt it in their missing hand. Touch their cheek, they felt their phantom fingers tingle. Touch the right spot on their jaw, they felt their phantom thumb. This made no sense under the old model. Ramachandran had a map in mind. A map every neuroscience student learns, called the sensory homunculus. It is the brain's internal body map, a region of cortex called the somatosensory cortex that dedicates space to every part of your body proportional to how sensitive that part is. Your lips take up enormous space, your back surprisingly little. And here is the critical detail. The area of cortex dedicated to your hand sits directly next to the area dedicated to your face. When the hand is amputated, its cortical territory goes dark. And what does the brain do with unused territory? It lets the neighbors move in. The face region expands. It bleeds over into the former hand zone. And now, signals from your face are being processed in a region that still has one job: to represent your hand. So you feel your face in your missing fingers. Ramachandran called this cortical remapping, and it proved something extraordinary. Your brain is not a fixed machine. It rewires itself in real time based on what it is receiving or not receiving. But Ramachandran did not stop there. He noticed something that would become one of the most elegant experiments in modern neuroscience. Many of his amputee patients felt their phantom limb was frozen, paralyzed, stuck in a cramped or painful position they could not escape because there was no limb to move. They had learned helplessness at the neural level. Their brain had last seen the hand in a certain position, perhaps at the moment of injury, and locked that representation in place. The phantom pain, in many cases, was the pain of a limb their brain believed was permanently, inescapably clenched. And then Ramachandran built a box. It was not complicated. A cardboard box divided down the middle by a mirror. You place your intact arm on one side. The mirror faces the missing arm's side. When you look into the mirror, you see a reflection of your good hand, but positioned where your missing hand would be. You flex your good hand, you open it, you move it freely, and your brain, watching that mirror image, receiving visual feedback of a hand moving in the space where the phantom lives, begins to believe the phantom is moving too. For many patients, the pain diminished. Some reported that a phantom limb frozen for years began to feel free. A mirror. That was all it took to partially override the brain's internal model with external visual data. Think about what that tells you. Your experience of your own body is not what your body actually is. It is a model your brain constructs, moment to moment, using every available signal. Touch, pressure, temperature, proprioception, vision, expectation. The brain runs a simulation of you. And pain, real, physical, undeniable pain, can emerge entirely from inside that simulation, with no physical source required. This is not a quirk of amputees. This is the operating system all of us are running. Researchers studying conditions like fibromyalgia, chronic back pain, and complex regional pain syndrome have found the same pattern. In many cases, the original tissue damage has healed completely. But the brain's pain map, its model of the body as damaged, did not update. The pain became self-sustaining, the signal persisting long after the signal source went dark. A neuroscientist named Lorimer Moseley at the University of South Australia has spent years studying what he calls the pain revolution. His central finding is that pain is not a measure of tissue damage. It is a measure of perceived threat. Your brain creates pain when it believes your body is in danger. And if your brain has learned, through experience, through trauma, through prolonged injury, to treat a region of your body as permanently dangerous, it will keep generating pain even when the danger is gone, even when the tissue is gone, because the threat map outlasted the territory it was mapping. This has transformed how scientists think about chronic pain. And it raises a question that should stop you cold. How much of what you feel right now, physically in your body, is real? The answer is all of it, but real does not mean what you think it means. Real means your brain generated it. It does not mean there is a source in your body causing it. Those are two different things. And for most of human history, we did not know they could come apart. You have never touched the world directly. What you call touch is your brain's interpretation of pressure signals from your skin. What you call pain is your brain's interpretation of threat signals from your tissue, or as phantom limb teaches us, from the memory of tissue that no longer exists. Your body, as you experience it, is an inference, a best guess, a model running in real time. Ramachandran called the brain a belief engine. Not in the mystical sense. In the mechanical sense, the brain forms beliefs about the state of your body, and it enforces those beliefs through sensation. Change the belief, give it new evidence, trick it with a mirror, and you change the sensation. That idea has spread far beyond pain research. It is now central to how we understand perception, emotion, and what it means to experience anything at all. The brain does not passively record reality. It actively predicts it. And what you experience is not the world. It is the brain's best guess about the world. Constantly updated, occasionally wrong. And here is where it comes back to you. Every time you feel that tightness in your chest before a hard conversation that never actually hurt you. Every time your stomach drops at a memory of embarrassment that is years in the past. Every time your body floods with a stress response to something that poses no physical threat, that is your brain running its model, predicting danger where data says there is none, generating sensation from architecture, not from injury. You are not simply a person who experiences pain. You are a brain that manufactures experience, drawing on history, prediction, and a body map that was written long before you had any say in the matter. A person with no hand feels their missing fingers burn. You feel anxiety in your chest before a meeting that has not happened yet. The mechanism is the same. The brain believes something is wrong. The brain creates sensation to match the belief. The sensation feels utterly, undeniably real. Because it is. It just was not sent from where you thought. Tonight, when something aches or tightens or pulls inside you, and you cannot quite name why, remember the hand that still burns in a body that no longer has one. Your brain is not reporting reality. It is building it. And sometimes all it takes to change what you feel is one small piece of new evidence, a mirror held at just the right angle, showing the brain what it needs to see.